right, so 5.1, we're continuing with our trig functions, but we're going to do different things with them. So we have these trig identities. We're going to be simplifying our trig functions and factoring trig functions, and in order to do that, we need to know our trig identities. So we have our reciprocal identities. These we should already know. The sine is 1 over cosecant, cosine is 1 over secant, tangent 1 over cotangent, and then the reciprocal ones is the same, so cosecant would be 1 over sine. We also have our quotient identities, so tangent is sine over cosine, which if you think about it, tangent was y over x, and sine was y, and cosine is x. So we can always switch out tangent with sine over cosine. Same thing with cotangent, we can switch it out with cosine over sine, or the other way around. And then we also have our Pythagorean identities. So that's sine squared plus cosine squared equals 1. 1 plus tangent squared is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. So these, anytime we see a trig function that's squared and we're adding it to either 1, or if you see sine plus cosine, sine squared plus cosine squared, you're probably going to use one of these. So anytime you see like a 1 and a trig function squared, you're going to want to use one of your Pythagorean identities. We have some more on the next page. We don't see them as often, but we have cofunction identities and even and odd identities. Example 1 actually is from 4.4, so we're going to skip it. We already know how to do that. It was on our last quiz and our last test. So we're going to look at example 2. So these are the types of questions we'll see in 5.1. Simplifying your trig expressions. So here I have sine times cosine squared x minus sine. So we want to try to change this equation and make it simplified. So we kind of have to think back on our algebra rules. Can I factor it? Do I have a greatest common factor? This one, all of our terms are in terms of cosine and sine, so it doesn't help us to change it into anything else. But do I have a GCF between our two terms here? What is it? Sine. So I'm going to take out the sine. When I take out sine, so I'm dividing both of these by sine, what am I left with? Awesome. Cosine squared x minus 1. All right, so now I want to see, do I have any trig identities that I can replace one of these with? Remember when I said I have a trig function squared, and especially if I'm adding or subtracting a 1 to it, I may use that. So we have our trig identity that is sine squared plus cosine squared is equal to 1. Now this isn't exactly like this, but can I make it look like cosine squared minus 1? How? Or I can subtract the 1 and subtract the sine. So I'm just going to rearrange this equation to make it look like cosine squared minus 1. So I'm going to move the sine to the other side and then subtract the 1. So now this is cosine squared x minus 1 is equal to negative sine squared x. So this cosine squared x minus 1 matches this exactly. So what does cosine squared x minus 1 equal? Negative sine squared x. So I'm going to take that and replace the cosine squared minus 1. So I still have that sine on the outside, and then I'm multiplying it times negative sine squared. Now what can I do next? I can multiply them together. So what is sine times negative sine squared? Awesome. Negative sine cubed. So a lot of these questions, we are just applying what we know using like with algebra, but using trig functions instead. So I know that I could have multiplied, if sine was x, I could have multiplied x times negative x squared, and that would become negative x cubed. So it may help just to think about it in terms of like x's and simplifying it that way. Let's look at example 3. So example 3 tells us we are going to factor each expression. So for A, I have secant squared theta minus 1. Now there's no difference that it says theta or x like it did in the last one where we had sine x. It's just a variable, so the secant is the important part. So let's think about this in algebra terms. If I replace secant with x, I would have x squared minus 1. How can I factor x squared minus 1? Awesome. It's the difference of squares, so I'd have x plus 1, x minus 1. Now I replaced secant with x, so in my answer I'm just going to re-plug in that secant. So secant theta plus 1 and secant theta minus 1. And this would be our answer. Here you don't have to simplify, we're just factoring. So the question just said to factor, that's all we needed to do. All right, now let's look at B. So same thing here. I'm just going to replace my tangents with an x and then factor it from there. So I have 4x squared plus x minus 3. Now how would I factor this? Awesome. Multiply the first times the last. Anytime we start with a leading coefficient that's not 1, you have to multiply the first times the last. So I get negative 12. What are two factors of negative 12 that add to 1? Positive 4 and negative 3. So this would be x plus 4 and x minus 3. Now what do I have to remember to do next? I have to divide by 4. If you ever start with multiplying, you have to remember to go back in and divide. So this would be x plus 1. Simplify the fraction if you can. What do I do if I can't simplify it? Move it in front of the x. So this would be 4x minus 3. Once I factored, I can just go back in and replace the x's with tangent. So this would be tangent of theta plus 1 and 4 tangent theta minus 3. So again, you don't have to replace it with x's if you can factor it right off the bat, but sometimes it may help, especially in the beginning, to see it a little bit better on how to factor when we put x's in there. So for example 4, we're factoring again. The only difference is here I have two different trig functions. This is like saying x squared minus y minus 3. Could I factor this? No, because I have two different variables here. So I need to make them the same variable. So what we would do is anything that is squared, or squared term, we want to look at our Pythagorean identities, because we can change the squared trig function to something different. So let's go back to slide 1 and look at our Pythagorean identities. So that's perfect because I have a cotangent here. So my trig identity is 1 plus cotangent squared is equal to cosecant squared. So I'm going to replace the cosecant squared with 1 plus cotangent squared. What do you think I should do next? Combine the 1 and the negative 3. Perfect. I'm going to combine my like terms. So I have cotangent squared x minus cotangent minus 2. Now we can factor. If you want to change it in terms of x, it'd be like x squared minus x minus 2. Let's see if we can just factor it leaving the cotangents. What are two factors of negative 2 that add to what? What am I looking for? What are they going to add to? Negative 1. So what are two factors of negative 2 that add to negative 1? Negative 2 and positive 1. So when I factor this, it'll be cotangent minus 2 and cotangent plus 1. And that's our answer. All right, let's look at example 5. So this one's a little bit different here. I'm simplifying. So I'm not factoring, just simplifying. Now, when I have multiple trig functions, like I have sine, cotangent, cosine, it may be helpful to change everything in terms of sine and cosine. So how could I change cotangent to be in terms of sine and cosine? What is it? Cosine over sine. Now again, here we have t's instead of x's. Same thing, just a different variable. Now ideally we'll want to simplify this so it's just one term. We don't have any pluses in it, just one thing. So what do you think I can do to condense this a little bit more to simplify it? Could I cancel out the cosines? But can I combine them? What's cosine times cosine? Cosine squared. So I have sine plus cosine squared over sine. So you could only cancel it out if you had a cosine on the top and the bottom, but they're both on the top, so we can multiply them. So that's how we got the cosine squared. Now, thinking back to algebra, how can I add a whole number and a fraction? I need a common denominator. So how can I make sine have the denominator of sine? I can multiply it by sine over sine. I'll make it sine over 1 and multiply it by sine over sine. So what is sine times sine? Sine squared over sine plus cosine squared over sine. Now that I have a common denominator, can I add these together? Yes. So I have sine squared plus cosine squared over what? Just sine. Does anything look familiar here? Awesome. One of our trig identities, our Pythagorean identities, is sine squared plus cosine squared is 1. So I'm going to replace that sine squared with cosine squared. Sine squared plus cosine squared with 1. So I have 1 over sine. Does this look familiar? This is cosecant. So all of this turned into cosecant. So example 6 says rewrite it so it's not in fractional form. Any suggestions? To make it so it's not a fraction anymore. You can't cancel out the ones because it's 1 plus sign on the bottom. Yes? If we multiplied by 1 plus sign, then we're changing the value of it. So we couldn't do that. Think back to when we had like complex numbers in our denominator. Let's try that. If we multiply by 1 minus sign, now we can't just multiply it on the bottom. What else do I have to do? Multiply it by the top too. So 1 minus sign on the top and the bottom. So on the top, it would just be 1 minus sign. On the bottom, I'm going to have to FOIL. So 1 times 1 would be 1. 1 times negative sign would be negative sign plus sign. And then sign times negative sign would be negative sign squared. Now I can simplify this a little bit more. Combine the like terms. So that sign, negative sign plus sign cancels. So it's 1 minus sign squared on the bottom. Now I have a 1 and a trig function squared. So that tells me I'm probably going to have to use one of my Pythagorean identities. What's my Pythagorean identity that has a sign squared? Sine squared plus cosine squared is equal to 1. How can I make this 1 minus sine squared? Subtract the sine squared. So what is 1 minus sine squared equal to? Cosine squared. So I'm going to replace this 1 minus sine squared with cosine squared. Now again, we're trying to get this to not be a fraction. So what do you think I could do next? Any guesses? What's the reciprocal of cosine? One over secant squared. So I could do that. Since it's cosine squared, I would just change it to 1 over secant squared. Now what happens when I have a fraction and a fraction? Keep change flip. So I'm going to change the multiplication and flip it to secant squared over 1. So then from here, I have secant squared x times 1 minus sine squared, or sine, 1 minus sine. So I just multiplied the tops together. And what happens when I multiply the bottoms together? What do I get? What's left in the denominator? 1. And if my denominator is 1, I don't need it. Did I get rid of the fraction? Yes. So then we're done. Now you could distribute the secant squared. That would work. With these questions, there can be like more than one right way to do it, more than one right answer. With a lot of these types of questions, it'll look like the example we did before where we simplify it and it's just one trig function. If you're adding two different trig functions, see if you can add them together. Maybe you're just multiplying two trig functions. We're looking for one term. So either we're multiplying two trig functions together or we simplify it completely just down to one trig function.